Okay, if you look here at this x to the fourth term, in the past I've told you to take out the GCF and go ahead and factor it, and we could do that here. I'm going to just take a little different approach to this problem. I'm going to pretend for a second that, well, instead of x to the fourth x squared, it almost looks like difference of squares, a squared minus b squared. If you look at it kind of in a funny way. So here's what I mean by that. Could we factor this in such a way, kind of treat it almost like difference of squares, where I put 2x here, and 2x here, and what's the square root of x to the fourth? That would be x squared and x squared. I'm just taking the square root of that, putting it here and there. They're all perfect squares. One of them's plus, one of them's minus. If I do it that way, I've kind of factored this. Now, I could further factor, and you can see there's an x in there I can take out. And of course, there's another x I can take out over here. That's x minus 2. And then x times x is x squared. So we get the same answer, but it's a little different way of thinking. That's what we're talking about here. There are other types of equations. We're kind of thinking about equations differently, and it'll allow us to solve some pretty intense problems, actually. So here we're going to try this one. Factoring by grouping. And it's possible we've done one like this, actually. We're going to group the first two. Remember, we put plus and negative there. And we group the next two. And so you take out the GCF this way. It's going to be x squared times x plus 3. Plus, and we'll take out the negative there because that 4 is negative. So negative 4 times x plus 3. The sign changes. And since that matches that, we can then regroup and say x plus 3 times x squared minus 4. I think we have done problems very similar to this, and then this breaks up even further. Hopefully it becomes obvious to you that that's difference of squares at this point. And x plus 2. That was not so different than anything we've done before, but it's to the third power. It's just a little tougher. Here, now we get a quadratic type equation. We might expect a quadratic to look something like this, x squared minus 3x plus 2. Well, we could factor that all day long. It's just a regular quadratic. This is very similar to that form. You see, if you look at that middle term, if you square the middle term, you would get this term, right? X squared is that. If you squared the middle term here, you would get x to the fourth. So it has kind of a feel of a quadratic, even though it's not exactly quadratic. So let's try to treat it like a quadratic. Here's what I mean by that when I say treat it like a quadratic. We're going to factor as normal. 2 and 1, that's really the only way to factor 2. But instead of x and x like I would normally put here, I know the first term is x to the fourth. So I've really got to put x squared and x squared here. Kind of assume that they're going to be equal. Now let's see if we can get this to work or not. Kind of factor like we would normally factor. So this one's, the last term is positive, the middle term is negative, so I know they're both negative. Does that work? Sure. In fact, we could break this up further, right? X plus 1 and x minus 1. And while we're at it, I mean, we might as well go all the way here and factor that one as well. It's kind of weird. That's a perfect square. It's easy to see. 2 is not really a perfect square. Like with 1, we took the square root of 1, square root of 1. So this is actually, if you think about it, of course it simplifies, but that's the square root of 1, and that's the square root of 1 that we put there. We took 1, and we square rooted it and put it here and here, right? Well, we're kind of doing the same thing here. So instead of, this isn't a perfect square, but we could factor it if we wanted to. Let's say square root of 2, square root of 2, and one's plus and one's minus. If you can see that, that's really the kind of stuff. We're taking just factoring up a notch from anywhere we've ever been before. So our solutions would be, x equals plus or minus 1, because those aren't really square root of 1, they're just 1s. And then x equals plus or minus square root of 2 from this. So we get 4 solutions for one problem. That shouldn't be a huge surprise because this is x to the 4th power. So you might expect typically 4 solutions there. Let's try this one. Let's see if there's another one here. Let's try this one. I like that. Okay. Does this kind of look quadratic? Again, we're kind of using that term loosely, but that's being squared. That's to the first power. It might almost look like this. Like it kind of looks like x squared plus 5x plus 6 equals 0, right? That would be a piece of cake to factor, right? We know how to do that all day long. It's kind of like that. Instead of the x, again, this term, if you square it, will equal that term. If you square x plus 2, you get x plus 2 squared. So rather than FOIL this out, combine like terms, do the whole 9 yards, I'm going to treat this as my new x right there. My x plus 2 is x. So I'm going to factor like normal. Okay, factor, factor. But instead of just putting an x right here, right, I'm going to put what really is there, which is x plus 2 and x plus 2. You can put it in parentheses if you want. And then here I'm going to put, let's see, factors of 6, like maybe 3 and 2. And let's see how that works. So 3 times 2 is 6. 2 times the quantity x plus 2 plus 3 times the quantity x plus 2 is 5 times the quantity x plus 2. Again, to add up to a positive 5, so this would have to be a positive 3 times x plus 2 plus a positive 2 times x plus 2 is a quantity of 5 times x plus 2. Now it's just a matter of simplifying what's in here and simplifying what's in here. This parentheses would be x plus 4. And if you add 2 plus 3, you get x plus 5. And so we have fully factored this. If we want to solve it, you'd say x equals -4 and x equals -5. It's brilliant. It took a lot less time than it would take to FOIL that out, combine like terms, and simplify all of that. Again, you have to not be too scared of what this looks like, and just think of this like your new x. X is being squared minus 6 times x plus 8. It's almost like you have to pretend you're factoring, x squared minus 6x plus 8. In fact, probably the easiest way to do this is what I call the W method. So the W method is this. I'm going to say W equals 1 plus 1 over x. So I'm pretending that is W. So I'm going to call this W squared minus 6W plus 8 equals 0. I'm going to go ahead and factor. You could call it x if you wanted to, but we already have an x, so I just called it some other variable. So I'll factor as normal. You get W, oh, this is easy. 2 and 4, I guess. Adds up to -6 minus 2 minus 4. So W equals 2 and W equals 4. However, I've solved for W, but that's not what I want. I want x. And guess what we have to do now? So now we've got to take what we just substituted in for W and replace W now. It's like a double substitution. That is going to replace W now. So it's like a brilliant substitution here. We say, well, 1 plus 1 over x equals 2. And then for this equation, we say 1 plus 1 over x equals 4. Now we're just going to solve those two equations. We subtract 1 over x equals 3. Multiply by x, 1 equals 3x. So x equals 1/3. We solve that. And here, subtract 1, we get 1 over x equals 3. Multiply by x, 1 equals 3x. Something seems wrong here. Sorry about that. Let me finish this one. I just figured it out. X equals 1/3 for this one. And that would help if I didn't make a mistake on this one. There we go. So getting back to here, sometimes it helps when you catch your mistakes. If you subtract 1 here and subtract 1, you get 1 over x equals 1. Multiply both sides by x, you get x equal to 1. So we get 2 solutions here. X equals 1/3 and x equals 1. And so double check the denominators. Yep, they work. So you've got 2 solutions for this one. And it's to the second power, so it shouldn't be a big surprise that we got 2 solutions. That's called the W method. You could have used the W method on this problem as well. If you look at this one right down here, right, instead of this, we could have said W squared plus 5 times W plus 6 equals 0, and then just off to the side say W equals x plus 2. Solve for W and then plug that in for W at the end. So it can take a tough problem like that that's tough to think through and help you solve it pretty easily. Let's look at one more here. So does it kind of look quadratic? Well, maybe. I mean, if you take this term and square it, do you get x to the 8th? Sure. So this is kind of like our x is kind of like our x to the 4th. That middle term is kind of like your new x here. So I might say W equals x to the 4th. Whatever that middle term would be, whatever W is. So this would be W squared plus 15W. And then let's go and do that one step. Let's move that 16 over by subtracting because we have to set it equal to 0. Go ahead and factor and solve that. This factoring with W should be really easy. 16 and 1 plus and minus. W equals 1. W equals negative 16. We're not done. We've got to plug this back in for W. So we go x to the 4th equals 1. Not such an easy problem. X to the 4th equals negative 16. So let's try this. This is just getting kind of intense here. So x to the 4th equals 1. What happens if I take the 4th root of both sides here? So 4th root of both sides, is that an even root? It is, which means, don't forget plus minus. So we get x equals plus or minus the 4th root of 1, or just plain old 1. Again, 4th root, take the 4th root of both sides, which means I need plus minus, so I say x equals plus minus. Now we didn't used to know how to do this with a negative, but we could take a 4th root of negative as long as we know there's going to be I on the outside. So I'm going to pull out that negative and say this. Now 4th root of 16. Can I do the 4th root of 16? If you know 16 is really 2 to the 4th, you might know the 4th root of 2 to the 4th would be 2. Or you could do square root twice to get 4th root, and you get plus or minus I times 2, or in other words, 2I. So we get those 2 answers and those 2 answers. Again, it was x to the 4th power, so that was to be expected. This is the end of the